Hey, what's up, everybody? Today we're just going to be recapping some of what we've done with the Texas Instruments calculator-based Ranger, or CBR, which you see pictured here on the left, or what we affectionately call the Death Ray. Don't worry, it does not harm students. Here's me, and I know I'm not that skinny, but we're just going to take a look at and refresh your memory about some of the things that we've done with the CBR. So what we did is we started just walking the death ray, right? So we started close, and then that's not what I wanted either. I don't know why it ungrouped itself. There we go. We just started walking the death ray. So we'd walk away from it, and what it did was it created this graph on the calculator, and I don't have anybody filmed doing it, just because I'd have to get a bunch of waivers signed to put people on the internet. So we'll just draw it out, and this hopefully will refresh your memory that when that happened, the graph usually started somewhere down here, which is low distance because they were close to the Ranger, and low time because it just started, and it went up. And we noticed a couple of things about that the person's that distance increased, and the line was increasing or going up, and it had as we've explored before, a positive slope. So slope is something that we've been talking about a lot, and we know that slope represents a couple of things. It's our delta y over delta x, so it represents some sort of change. It represents how steep a line is, and we also know that it represents something else, is somebody's speed. So we looked at that, and then we noticed that if someone started far away and then walked towards the death ray, that what happened to this line now is it was not increasing, but it was going down, because they had something that was, they had a distance that was big. So it's starting to the top left, and then as time increased, their distance got smaller. And now instead of having a positive slope, this thing now has a negative slope. And I didn't mean to erase those other lines. So it now has a negative slope. All these things about slope are still true, except now instead of their distance increasing, we notice that their distance is decreasing. So a decreasing distance is coupled with a negative slope. And what we're able to do with that is then we looked at equations of these lines. For example, if I'm standing, let's say, 3 feet away from the death ray, let's say this starting point is 3 feet away, and let's say that my rate or my speed, let's say that my speed here is, let's see, I'll get rid of some of this other stuff. Let's say that my speed walking away from it was, let's say I'm walking at 2 feet a second, which is no big deal. I think I can walk that fast. So 2 feet per second. That when I did that and we looked at the equation, that the equation that we matched that line to using the calculators was 2x. And remember, I'm walking away from it, so my distance is increasing, therefore a positive slope is 2x plus 3. And how would that change if I was walking towards it? Well, the only thing that should have been different now is that if I started here, farther away, sorry about that, if I started farther away, and, well, no, not starting farther away. Let's say that I still started 3 feet away, but this time I'm walking toward the death ray, then Oh boy. Sorry. It doesn't want to respond. Forget it. Okay. So I'm walking toward the death ray. Then now the only thing that changes about that is I'm still walking 2 feet a second. I still started 3 feet away, but now I want to show that my distance is decreasing, and I do that with a negative slope. Remember in our studies in slope, we know that if I look at these two numbers here, the 2 and the negative 2, that they're both the same speed. The only difference is that the positive means that y value is increasing, distance. The negative value means that y value, distance, is decreasing. So it doesn't have anything to do with how fast I'm going. The speeds here are the same. It just has to do with what direction I'm going. So in red here on top, 2x plus 3, this means that my distance is increasing. I'm walking away from the death ray. And in the second equation, it means that my distance is decreasing or I'm walking towards it. And we also know that that's what it means with the line, that the negative slope just changed the direction of the line, up or down. So it means that we can ask questions like this and also answer them. If a person walked the death ray starting 10 feet in front and walking 4 feet per second away the death ray. Sorry, it should say away from the death ray. And what is the equation of the line that they're going to make? So we know that we've got a speed and we've got a starting distance, which is plus 10 because they're 10 feet in front of it. And now we need to decide, is that slope, is that for positive or negative? Well, because they're walking away from it, it means that their distance, which is our y variable, is increasing. So what we're going to do there is we're just going to leave it as a distance increasing, so positive slope. So now the second part of this question, if that person walks toward the death ray instead of away, how will the equation change? And the only thing that's going to change is that the distance is still going to be a starting point of 10 feet away, starting distance. It's still going to be a speed of 4, but now we need to indicate that their distance is decreasing with a negative slope. So this math, this equation helps us sort of tell the story of what's happening, or at least to summarize part of the story. And I'm summarizing it mathematically. So if a person walked the death ray and made this equation, y equals 3x minus 2, describe in detail what they did. And this is a little bit different than what we saw before, because the 3 tells me that they're walking 3 feet per second. But now this negative 2 is different than what we've had before. A negative 2, well, let's think about that for a second. If on the previous page, if the plus 10 was 10 feet in front of it, then minus 2 would be they started 2 feet behind the death ray. So they started 2 feet behind the death ray and then walked sort of through the death ray and kept going. So what that would look like here is the death ray, I'm 2 feet behind it, and then I'm walking at a rate of 3 feet per second. So 2 feet behind it at 3 feet per second, here's 1,001, and then I'd keep moving. So then it wouldn't actually pick me up on the death ray until about just a portion of a second. That would give me enough time to get in front of that sensor. So again, just a quick recap. If you have any questions, please see me. Take care.